Let's look at this word optical. What we want to do is see how many different ways can the letters of this word be arranged so that the vowels always come together. So let's start here. O-P-T-I-C-A-L. We've got all 7 letters there, right? So in this case, let's do this down here. N is equal to 7. And what we want is all the vowels come together. So what are the vowels here? O, I, and A. So we've got 3 vowels, right? There's 3 of those. We want them all to come together. So here's where we could put them, right? I'm thinking that the vowels could be here in the first 3 positions. They could be here. They could be here. And they could be here. And they even could be here, right? So there's, how many ways could we put those vowels? There's 1 place for them, 2 places, 3 places for them, 4 places, and 5 places. So I'm thinking that the vowels could go the first 3, the second 3, third 3, fourth 3. They can't start over here, right, because there's only 2. So it looks like there's 5 places that we can put those vowels. So our first decision is, what position should we put the vowels? In what position should the vowels go? We have 5 ways to make that decision. Then, once we've decided on a position for the vowels, we've got 3 vowels. How many ways can we arrange those? So suppose we wanted this leftmost position. We could put any one of the 3 here, and then 2, and then 1. So this is going to be a 3 factorial here. And then, what do we have left? Well, then what's left are the consonants. So what consonants do we have left? We have a P, a T, a C, and an L. There's 4 of those, so we could arrange those any one of 4 ways, right? If we put the vowels here, we have 4 places left for those consonants, and we could put any one of the 4 here, then 3, then 2, then 1. So this is going to be a 4 factorial. So we could do it that many ways, and when I multiplied those together, I got 720. And here, number 12, we've got a question paper that has 2 parts, P and Q, and each containing 10 questions. You know what I'm thinking here is that what I like to do is put things into boxes here. So what I have there, I have 10 P-type questions, 10 Q-type questions, and just to keep track, we have 20 questions altogether. That might be more for what we work with in probability, but we're going to select 12 altogether. We're going to select 8 from A and 4 from B. So how many ways can we do this? Okay, well, first of all, we don't really have A and B. What we have for P, we're going to select 8 of those, and for Q, we're going to select 4 of those. So we've got 2 decisions to make here. What are we going to choose for the P questions, and what are we going to choose for the Q questions? So for P, there's 10 altogether, and we want to choose any 8. So no order is implied here. What we have is this, a combination of 10, just choose 8, right? How many ways can we choose 8 things out of 10? So 10, choose 8. And then similarly, for these Q questions, we've got 10 of those, and we want 4. So this is going to be 10, choose 4. Okay, so there's our answer. 10, choose 8, times 10, choose 4. Okay, the mathematics is done. The rest of this is just mechanics, computation. So when I did that on my calculator, I got 9450. And here in number 13, we've got 3 places, P, Q, and R, such that the 3 roads that connect P and Q. All right, so if we start at P, here's what I'm thinking. I'm going to draw this. Here's P. We've got 3 roads to get to Q. So here's Q. I could go that road, or that road. So I have 3 choices for that position, for that decision. And, okay, and is the times, right? And times. Now, there are 4 roads that connect Q and R. So now we want to get to R. So maybe R is over here. So we got 4 roads, 1, 2, 3, and 4. So there's 4 ways to make that decision. So 12 ways to make all the decisions from getting from P to R. So problem 14 tells us that there's an organization that can choose a president and a vice president in this many ways. So how many members are in the organization? Well, just to get an idea of how to do this, what if, okay, so I'm just going to write an example here. So just for example, what if there were, say, 10 people in the organization? Then you have to choose a president and a vice president, and you could choose any one of the 10 here, and then there's one less person to choose from here, so that would be a 9. And then this would give us 10 times 9 being 90. Now that'll give us an idea of how to actually work this problem, because this is kind of backwards. We're given the total number of ways to choose, and now we want to get this number right here. So let's see what we can do here. We're going to have a president and a vice president, and when we make that multiplication, we know we get 56. Now, how many people are in the organization? Well, for the president, we could choose any one of those people that are in the organization. And why don't we do this? Let N or X or some letter represent the number of people in the organization. So I'll use an N here. So there's N people from which we could choose to be the president, and then there's one less than that to give us the 56. So let's multiply this out together and see where it takes us. So N times N minus 1 is 56. Multiply through, we'll get N squared minus N equals 56. You know what, I think I'm going to go up here now. This is quadratic, right? It's quadratic, squared term. So I know how to solve them. Get everything on one side, 0 on the other. So our plan here is to subtract this 56 from both sides, and that will give us N squared minus N minus 56 equals 0. Let's factor this, hoping we can factor it. We'll get N and N, and now this 56, I've got to find two numbers that when I multiply them together I get 56, but when I add them I get a negative 1, or a 1 anyway. So here's what we could do. 56, we could use 56 and 1, but these do not, right, these do not differ by 1. So what I'm going to do is I'm going to cut in half and double, keep this at 56. So I'm going to get 28, cut in half and double, 28 and 2. These still don't differ by 1, right? If I add them, I get 30. If I subtract them, I get 26. So the 28's even, cut in half and double again. So how about 14 and 4? Still don't differ by 1. Cut in half and double, 7 and 8. There we go. Those differ by 1, so I'm going to put a 7 in one place, 8 in the other. Now, the order doesn't matter, right? I could have put the 8 here and the 7 here. The 56 is negative. So these two numbers have opposite signs, and I'm going to put that middle negative sign with the larger of these two products.